All right, so we are starting Chapter 6 in Workplace 30, Chapter 6, Transformations. And we were talking about single transformations in 6.1. So, what is a transformation? The movement of a shape or an object by changing its position or its size and or its shape. So to transform something means to turn something into something else, more or less. So if you think about it, let's say we have this big red circle here, the easy button.
That was easy.
Yes, it was. And if I move this, slide it over, that's a transformation. The original is over here, and the transformation is now over here. That's an example. If this were to be enlarged, that's the transformation as well, or reduced.
That was easy.
Wasn't it? If it's not a circle,
That was easy.
all right, you got it. Okay, you can hand those out. That'd be great. Thank you very much. So if we have like a shape and we stretch it somehow, that's a transformation too. So there's different types. The easy ones would be the movements and the enlargements or the reductions. Those are the easy ones. The different ones are like the stretches where you like pull and contort and stretch. So we'll see what we get into here in this section. But a movement of a shape by changing its position, size, or general shape. There are a few other, other types of transformations that you need to know about. So a translation is a horizontal or vertical movement of a shape or object. So the size and the shape remain the same. It's just simply moved either left, right, or up, or down. So that is specifically called a translation. So if you think about it, what's the root of translation? It's translate. So if you have a message in one language and you want to translate it to another language, you're simply moving it from one language directly over to another language. You're saying the exact same thing, just in different words. So that's kind of like, here's one language, you're just moving it over to another language. The same message is just moved. Okay, another type of transformation would be a reflection. And this is sort of like a flip, okay? So if I have my calculator here, and I want to reflect it, it's sort of like it flips like this, okay? Now, you're not going to see the keyboard side if I keep it like that, but think about it this way. It's flipping down, right? And so all of a sudden it's an up, down, and then it's a down, up, and so on. So it flips, or your hand, right? If you rotate it around kind of a line, like a reflection line, that's what it looks like as a reflection. If you have a mirror, okay, your image of your face or your hand or whatever's in the mirror, you have the object, your hand, and then you have a reflection in the mirror, and it's always kind of a flipped, right? It's flipped. So a reflection is also called a mirror image, and it's created by transforming an original image over a reflection line. And so in this case, this triangle up here is reflected about the x-axis. That's the reflection line, and it's flipped vertically down here. Okay? That's number 2, a reflection. So we've got translation, a move, and a reflection. Third one we're going to talk about here, it's called a rotation. And that one's easy to understand too. If you have an object like this and you rotate it, you simply pivot. It pivots around some kind of point. All right? The point could be on the object, so you could pivot, around a certain point that's on the object like this. That's rotating it. Or you could pivot it around a point that's not on the object, that's away from the object, and it could look kind of like this. It would rotate around some given point in space. So the movement of a shape or object around a fixed or a point that doesn't move. Okay? So do you understand the differences between those three? A straight slide, a translation is also called kind of a slide, a reflection, and a rotation. Any questions there? No? Okay, one more. This is a word that maybe you haven't heard much of before. It's called a dilation. And if you may have heard this phrase, your pupils are dilated. Okay? That means your pupils, the black part of your eye there, is really big, dilated. It's gotten bigger. So when we talk about a dilation, we talk about an enlarging or a reducing of a shape. So it's not a stretch or a contortion or a twisting or anything like that. It's simply taking the original proportion of dimensions and you're just making them bigger. So it's really the same shape but bigger, or the same shape but smaller. Okay? So a dilation is the enlargement or reduction of a shape or object. All right. So now that we understand these new terms, let's do some examples. A translation occurs when a shape or image moves up, down, right, or left, without changing its size or its shape. Each vertex of the shape will move the same distance in the same direction. So this example says, translate the following shape 6 units to the right and 2 units down. So you don't have to copy this one down. If you just watch along with me here, I'll show you kind of how this works. So what we're going to do is we're going to identify, so we get a little bigger for you. We're going to identify the points. So there's A, there's B, and C, and D, and E. And so if we want to translate this 6 units to the right and 2 units down, that means that each point on the polygon, each point on this shape, moves those units. So if we have A here, I'm going to go count 1, 2, 3, 4, 5, 6 to the right, and then I'm going to go 2 units down, and there's my new A. And you'll see that sometimes, I don't know if you'll see this in this next page or not, but the new point or the reflected image, the translated point, will have a little tick mark beside it, and that's called like a prime symbol, so A prime. Okay? So that's 6 to the right, 2 down. Well, B does the same thing. 1, 2, 3, 4, 5, 6, and 1, 2. There's the new B. B prime. And all of these other ones too. 1, 2, 3, 4, 5, 6, 1, 2. 1, 2, 3, 4, 5, 6, 1, 2. And then 1, 2, 3, 4, 5, 6, 1, 2 right here. So this is E prime, this is D prime, this is C prime, and we said that one was B prime. So if we connect the dots, just like the original figure, I now have my translated image. Okay? So it should be, maybe my lines look a little thick, but it should be the exact same shape, the same size, even oriented the same way, right? Nothing is rotated. And so it's just a slide and a slide. It's a translation. And if the question asks you, what is the coordinates of C prime? Well, you know that C prime is down here, and so you remember how the coordinates move. We always do X first, and we go 1, 2, until we get in line with C prime, and then we go 1, 2, 3, 4, 5. So the C prime coordinates are positive 2, negative 5. That's this point, 2, negative 5. Everyone remember that? Do you remember doing that? The new point is not 6 units and 2 units. Like, that's not the new point at all. It's not like 6 comma 2 or anything like that. You always take it from the origin, this middle point right here. Okay? All right. So, let's see what this, okay. Well, that's just an explanation, and there you go. There's the new one which we just did. Okay. Okay. So, what I'm going to get you to do is, we're going to do some build your skills questions here. So we'll do number 1. So these are the coordinates for the actual shape, and question number 1 says, translate this shape 5 units to the left and 3 down. So each point is going to go 5 to the left and 3 down, and then you put the new point that corresponds with it. So take a moment to draw the image of that. So there's a few different ways you could do this. You could take each point and literally go 5 left and 3 down, 5 left, 3 down, plot the points. Or you could, if you want a little bit of a shortcut, you know that the shape, it doesn't change shape or rotate or anything. So check this out. A and E are 1, 2 units, 1, 2 units. 2 units over, 2 units down. So if I know this is A prime, I know that I go 1, 2 units over, 1, 2 units down. That's E prime. So that might be a little easier to do. Look at this. C is 1, 2, 3 units under E. So I'm going to go 1, 2, 3, and there's my C prime. So you can probably, use your head and cut some time off this if you want. D relative to E, 1, 2, 3 over, 1 up. 3, 1 up. Connect those points and try and make them as straight as lines as possible, okay? Yeah, and there should be your translated image should look something like that. Now it also says, what are the coordinates of the vertices? So vertices, if you're not sure what that term is, the vertices means the corners. So all of these letters here. So on the side, list the coordinates for A prime and for B prime and so on. Okay, so do that when you're done drawing your shape. One more. So there's your build your skills number 1, and those are the coordinates for the new points that we generated. Remember, always start from the origin and count left or right first. So for A, I have to go 1 unit left, and then so that's the -1 right here. And then I have to go 1, 2, 3 units up. Where's my 1, 2, 3 units up? And that's my second part of the coordinate there. So 1 left, 3 up to get to A prime. 2 to the left, and 0 up or down. So that's where I get my coordinate for my B prime. All right. So when you're done that, you can go ahead and work on question number 2, which is right here. It's a parallelogram, and it is translated such that vertex A moves to the coordinate 2, -1, and it's shown here in the diagram. So there is the coordinate 2, -1. Draw the other vertices of the translated parallelogram and state their coordinates. So if this is where the new A is, where's the new B, the new C, and the new D? So take a few moments to do that. Okay, so as we look at the question number B, it says how far does the parallelogram move horizontally and vertically? So what is the shift here? Can anyone tell me? Looking at the 2 points that we've already looked at here. Whoops, let me zoom in there for you. So you guys have finished this, right? The parallelogram moves from A right here. How many units horizontally and how many units vertically? What would you say? Looking at your diagram now, this whole parallelogram has shifted to where? Or if you haven't got it quite finished yet, where does A prime come from? Like, how many units do we move A to get to A prime? How many units, and are we moving to the right or left? From here, we're going to the right, okay? How many units are we going to the right? So count the squares. How many? 10? Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Looks like 9. Close. 9 units to the right. Okay. All right. And then, do we have to go up or down? No. We have to go down. 1, 2, 3, 4 units down. Okay, does that make sense? That's the translation, right? So you finished the rest of that parallelogram, but I also want to go over just really quickly a couple questions from this page, and then this will be kind of the end of our lesson here, okay? So let's get through this. So which one of these right here is a translation of the original ABCD parallelogram? Which one would you say is the translation? Which one is it?
1.
Okay, you say 1, you say 3.
1.
You say 1? Okay. Why did you say 1? Anybody want to tell me why you said 1? Okay, yes, very good. So in a translation, we're not changing shape or size. right? So it has to be the exact same shape, just slid over. And yes, in number 1, all the sides and all the angles are the exact same as the original. This one, you see this top angle here, not the same. And number 3, obviously, there's a lot different there. Okay? So that's that. And so number 1 is the reflection there. So one more question here. If you're given a map like this, and you've got grid units here, let's say you're at the sports field, and you want to go to the store. How many blocks, if these are all blocks, how many blocks do you have to go, and in which direction? So remember, this is north. What is this direction here? What's this one? East. What's this direction? South. And then what's the direction to the left? West. Never eat shredded wheat. That's what I learned when I was a kid. There's lots of different things you could do for that, right? So from the sports field to the store, how many blocks and in which directions? What would you say? You want to go from the sports field to the store. What do you got? 4 to the right. Okay, 1, 2, 3, 4. If you want to go to the store, you actually have to go 5 blocks. And when you say right, if I'm asking you directions, what direction is that? East. So 5 blocks east. Does that make sense? See that? Going to the right, 5 blocks east. Now, how many blocks and in which direction do you have to go now to get to the store? You have to go 2 blocks what? South. Okay? Does that make sense? Okay? All right. So that's the other kind of thing here. And yeah, so there's going to be the rest of these little build your skills questions for you to consider. So there's number 4, and it asks you how many grid units does you have to travel, northeast, southwest. So you just answered that question. Okay, now we'll do this in our next section right here.